Hey everyone, welcome back to the channel. Today we're diving into the world of operating systems, specifically the ones you really need to know for your B.Tech syllabus. We're going to break down the different types, what makes them unique, and why they matter. Think of an operating system like the brain of your computer. It manages everything from the software you use to the hardware that makes it all work. We're talking the core stuff here, and understanding the different flavors of operating systems is key, whether you're building software or just trying to ace your exams. So, whether you're just starting your B.Tech journey or need a quick refresher, stick around. We're going to simplify these operating system concepts and give you the knowledge you need to succeed. Let's get started. First up, we got to pay respect to the OG's batch operating systems. These were some of the earliest operating systems, and they worked a bit differently than what you might be used to today. Imagine submitting a bunch of punch cards with your program on them, then waiting your turn for the computer to process them all at once. That's batch processing in a nutshell. No fancy graphical user interface here, no sir. You interacted with the system through these punch cards or other offline methods, and the jobs were processed in batches, hence the name. Think of it like a restaurant with only one chef and a long line of orders. The chef works through each order one by one, and you get your food when your order is done, no matter how long it takes. Now, batch systems were great for their time because they automated a lot of tasks that used to be done manually. They were efficient for processing large volumes of data, especially when the interactions with the user were minimal. But the downside? No real-time feedback, and you had to wait for your entire batch to be processed before you got any results. Imagine waiting days for a simple program to run. That's why batch systems aren't as common today for everyday computing, but they're still used in specific areas like processing payrolls or scientific calculations, where you need to crunch a ton of data without user intervention. So even though they're old school, understanding batch processing gives you a foundation for how operating systems have evolved over time. It's like learning about the first cars before jumping into a Tesla. You've got to respect the roots. Next up, we're talking time-sharing operating systems. Now, as computers got more powerful, people wanted to do more with them, and they wanted to do it all at the same time. That's where time-sharing comes in. Imagine you have one CPU, the brain of the computer, and multiple users who all want to use it. A time-sharing system acts like a super-efficient traffic cop, directing traffic and making sure everyone gets their turn. It divides the CPU's time into tiny slices and gives each user a slice. It switches between users so quickly that it creates the illusion that everyone is using the computer simultaneously. Think of it like juggling. A skilled juggler can keep multiple objects in the air at once by quickly switching their attention between them. Time sharing is similar, rapidly switching between users' tasks to give the illusion of simultaneous processing. This was a huge leap forward because it made computers much more interactive and accessible to multiple users. No more waiting for your turn in line like with batch processing. Time-sharing systems formed the basis for the interactive computing experience we have today. From the early days of mainframes to modern personal computers, the concept of sharing CPU time efficiently has been crucial. It paved the way for multitasking, where you can run multiple programs at the same time, like browsing the web while listening to music. So time sharing is all about making the most of limited resources, keeping everyone happy, and ultimately, changing the way we interact with computers. Chapter 3. Distributed Systems Teamwork Makes the Dream Work. Now let's talk about distributed operating systems. These are all about teamwork, bringing together multiple computers to work as one supercomputer. Imagine a network of computers, each with its own resources and processing power. A distributed system ties them all together so they can share resources and work on tasks collaboratively. Think of it like a team of superheroes, each with their own unique abilities. Individually they're strong, but together, they're unstoppable. Distributed systems are like that, combining the power of multiple computers to tackle complex problems that would be impossible for a single machine to handle. Now there are different ways to distribute the workload. You can have a client-server model, where one computer acts as the server, managing resources and distributing tasks to the client computers. Or you can have a peer-to-peer model, where all computers have equal status and share resources directly with each other. Distributed systems are used in all sorts of applications, from large-scale web services like Google Search, which handles billions of requests daily, to cloud computing platforms like Amazon Web Services, which provide on-demand computing resources. The key takeaway here is that distributed systems are all about scalability and reliability. If one computer fails, the others can pick up the slack, ensuring continuous operation. So, if you're dealing with massive data sets or need a system that can handle a ton of traffic, a distributed system might just be your new best friend. Chapter 4. Network Operating Systems, Connecting the Dots. Let's talk about network operating systems. These are all about connecting computers and peripherals, creating a seamless network where everyone can share resources and communicate with each other. Think of a network operating system as the glue that holds a computer network together. It provides the infrastructure for devices to connect, share files, and access shared resources like printers and scanners. Now, network operating systems come in different flavors, from small office, home office, SOHO networks, to large enterprise networks. They typically offer features like user management, security, and resource sharing. Imagine you're in an office with multiple computers. A network operating system would allow you to log in from any computer on the network, access your files, and print documents to a shared printer. It simplifies network management and makes collaboration much smoother. Network operating systems also play a crucial role in internet connectivity. They provide the necessary protocols and services for computers to communicate with each other over the internet. So next time you're browsing the web or checking your email, remember that a network operating system is working behind the scenes to make it all happen. Whether you're setting up a home network or managing a large corporate network, understanding the basics of network operating systems is essential. They're the unsung heroes of the connected world, enabling us to share, collaborate, and stay connected. Chapter 5. Real-time Operating Systems, Living on the Edge. Finally, let's talk about real-time operating systems, or RTOS for short. These are the speed demons of the operating system world, designed for applications where timing is absolutely critical. We're talking about systems that need to react to events instantly, with minimal delay. Think of systems that control things like car engines, industrial robots, or medical devices. In these scenarios, even a tiny delay can be catastrophic. Unlike general-purpose operating systems, which prioritize fairness and resource utilization, RTOS prioritizes predictability and responsiveness. They guarantee that tasks will be completed within a specific time frame, no matter what. Imagine a self-driving car approaching a red light. The RTOS needs to process the sensor data, apply the brakes, and bring the car to a safe stop, all within milliseconds. There's no time for the system to get bogged down with other tasks or delays. RTOS achieves this real-time performance through specialized scheduling algorithms and resource management techniques. They're designed to handle interrupts quickly and predictably, ensuring that critical tasks are always given the highest priority. So, while you might not interact with an RTOS daily, they're working behind the scenes in many critical systems that we rely on. From keeping airplanes in the air to regulating medical equipment, RTOS plays a vital role in our increasingly automated world. That's it for today's video. I hope this helps you get a better understanding of the different types of operating systems for your B.Tech syllabus. We've covered a lot of ground, from the early days of batch processing to the real-time responsiveness of RTOS. Remember, operating systems are the foundation of modern computing, and understanding their different flavors is key to navigating the world of technology. Whether you're building software, managing networks, or simply using a computer, this knowledge will serve you well. If you found this video helpful, hit that like button and subscribe to the channel for more tech breakdowns. And don't forget to hit the bell icon to stay notified about new uploads. See you in the next one.